So today we're going to learn how to graph and slope-intercept form. So we're going to review the parts of that equation before we begin. So slope-intercept form gives you the slope and the y-intercept of the line in the form of an equation. So let's just back up here, and x and y-intercept are the points that your line intersects the y-intercept or the x-intercept or the x-axis. So slope-intercept form is in the form of y equals mx plus b, where the m represents the slope and the y is represented by the b. We'll look at this a little bit closer. So when you have it in this form, you know right away what the slope of your line is by looking at the coefficient x, and you know where the point is, where that line will cross the y-axis by looking at what's being added or subtracted to the end. So let's look at an example here. Here's an equation, y equals 1/2 x plus 3. So looking at the equation, we can pick out the two important things here, which is the slope and the y-intercept. So in this case, your slope would be 1/2, it's the coefficient x, and your b is 3, so that means your y-intercept is 3. So at 0, 3, that line will go through the y-intercept, and it will go at a rate of up 1 over 2, up 1 over 2, because the slope is 1/2. So sometimes you'll get an equation that's not in slope-intercept form, but you'll be asked to find the slope or the y-intercept. So it's a quick fix to just move some of your terms around so that you can get the equation into slope-intercept form first, and then find the slope and the y-intercept. So we have an equation here that's in standard form, -4x plus y equals -10. So let's get that in slope-intercept form by solving for y. That would mean getting y on the left side of our equation by itself. So in order to do that, we need to deal with this -4x. So we know that in order to in the inverse operation for subtracting 4x would be adding 4x to both sides of the equation. So if you do that, you know that you will be able to cancel this out, leaving just your y. So we have y now by itself on the left side, and then I chose to put the 4x and then followed by the -10 just so that it would be in the form we're looking for. So it makes it easy to find our slope. So now our slope is 4, and our y-intercept, -10. So what that tells us is that that line goes through the y-axis at -10, 0, -10, and the slope is 4, or 4 over 1. You know, we can make a slope into an equation or into a fraction so that we know the rise and the run. So this line would be going up 4 and to the right 1, up 4 to the right 1. So knowing that we can find the slope and the y-intercept given an equation, it makes it very easy to graph it. That's why sometimes we put equations in this form, because it's easy to graph. So to graph this particular line, y equals -3x plus 4, we identify that slope and the y-intercept and then use that information to help us graph it. So our slope in this case, right here, we're going to make that into a fraction. So we have a rise and a run, and our y-intercept is 9. So we're going to start with graphing our y-intercept. So 0, 9, according to our equation, that's where that line will cross the y-intercept, and that's always your first step. But once you have that one step, you can use your slope, which is -3, or -3 over 1, to find your next point. So this line is moving, or its rate is down 3 to the right 1. So 1, 2, 3 to the right 1. Down 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. And then we can connect it. And it's just like that. So again, we graph our y-intercept first, get that point on our graph, then use your slope to find the next point, maybe a couple points to help you draw a straight line. What you have to remember is that when you're using that slope, you're always applying that rise and run to the y, starting at the y-intercept. Some people make the mistake of thinking you start at the origin and go down 3 to the right 1, and they would connect these 2 points instead. So remember that when you're using that slope, you have to begin at your y-intercept and then use the rise and the run. Just to show you what these were. So that y-intercept was 9, and the rise over run was -3 over 1. All right, so let's try this one. You can pause your video right now, write down your y-intercept and your slope that you get from that equation, and then graph in that order. Pause the video and then come back on to check your answer. Okay, so we have a y-intercept of 6, which tells us 0, 6 is the y-intercept right there. Then we're going to use our slope of 2 over 1, which rise over run, which means I'm starting at this y-intercept and I'm rising 2, running 1, rising 2, running 1, and connecting them. So I also can kind of do that in reverse to get the points on the left side of my y-intercept by going down 2 to the left 1, down 2 to the left 1. Sometimes depending on your coordinate plane, you may have to like reverse your slope to get points going in the other direction just so that they fit on your graph. So that was the answer. All right, so let's go ahead and try these. So this would be a good time to pause the video, identify your slope, identify your y-intercept, and then play the video again to double check. So go ahead and pause and work out this problem. Okay, so here's the slope and the y-intercept, which we get from the equation. We begin by graphing the y-intercept was 0, 5, and then use your slope, which is down 1 to the right 4, down 1 to the right 4 to draw your line in. Here's another example. Go ahead and pause your video and work on this one, then come back to check your answer. All right, so here is your slope. I like to write it as a fraction just so I can clearly see my rise and run. There's my y-intercept, and this should be a negative, definitely a negative because we have -2. So we start with that. We begin with graphing that y-intercept, which would be at -2, and then our slope up 3 to the right 1, up 3 to the right 1, so we have a couple points on there, and then we can graph our line. Sorry, that's not the straightest of lines. All right, so we learned how to find the slope and the y-intercept given a line in slope-intercept form, and we also use that information to graph it.